All right, folks. This is chapter 11, and you can find this information on page 294 of the book. Page 294 of your book, chapter 11, and we're going to start talking. We're going to start talking about the continents, and particularly something called continental drift. We're going to talk about a guy named Alfred Wegener and Pangea and all these other sorts of things. So let's get started with the notes. Again, this is nice because you'll be able to pause this whenever you want. So it's okay to pause it while you're writing things down and continue the video. I'm going to try to make this pretty short, so we'll hopefully be done in 10 or 15 minutes. So here we go. This is chapter 11. It's on page 294, and we're going to be talking about this guy here named Alfred Wegener. Alfred Wegener, and that's how you spell his name with a W there. Okay? Alfred Wegener was a German scientist, and he proposed this idea that he called continental drift. And that was the idea that if you take a look at the continents, he proposed that they possibly had at one time been in a different location. And Alfred Wegener proposed this idea in about the 1890s, so there wasn't a lot of widespread support around this. It's very easy to notice, if you've ever looked at a map of the world, that it appears the continents have some sort of puzzle piece type shape where you can put the two of them together, especially right here where you have South America and Africa. It almost looks like the two of them could fit together. So previous to good maps, so someone who makes a map is called a cartographer, and previous to these explorers traveling the oceans and mapping these kind of things, we would have had no idea. But in the 1890s, maps were becoming more detailed and they were becoming better. Alfred Wegener looked at these maps and said, there's some sort of correlation here between the way the continents fit together. And he proposed that at one time they were actually together, so this tip of South America would have fit in with the tip of Africa here. And he called this theory, the theory that the continents were moving, he called it continental drift. And so we're going to talk about that and continental drift and Alfred Wegener here. So here's a little talk about who Alfred Wegener is.
Do you have a Ch11 here?
I don't, I'm sorry.
Okay.
Sorry about the interruption, but here's Alfred Wegener here. He's a German scientist from the late 1800s and the early 1900s. He proposed the theory of continental drift. Okay, so he proposed this idea called continental drift. And the idea of continental drift, the definition of continental drift is this, is that the continents have moved horizontally to their current locations, so that they have moved over time. I mean, this is a millions of years process. But he realized there must have been something going on here based on the way they fit together. He would go on to spend his whole life trying to prove this idea of continental drift. Okay? So he came up with this idea that at one time there was a mass supercontinent, and he called this mass supercontinent Pangea. And this was all the land masses put together. Now, just to give you an idea of what Pangea might have looked like, here's a great example of it. All the land masses of the world were kind of all crunched into one. You can see here, you could almost walk, I mean, there at one point, it's safe to assume you could have walked from South Carolina across just a small boundary and be in Africa. Or definitely you could have walked from Brazil right straight into Africa, or from Africa straight into India. These sort of things is what the idea of Pangea said, this mass supercontinent. And so this 200 MA means 200 million years ago. So again, relatively speaking, geologically speaking, that's not too long ago. So it does take a really long time, 200 million years. But the Earth has constantly been changing the shape of its continents, which is really used to the one that we have right now, because it's been going on for the last, we've known about it for the last 6,000 years. Okay? So that was the name of the mass supercontinent. He called it Pangea. He would go on to spend his whole life trying to prove this idea of Pangea. And so he would look all over the world for clues and things like that. And he came up with 3 specific types of clues. And the first type of clues that we're going to talk about is fossil clues. And this was where he spent the bulk of his time, because he liked fossils and he liked to dig, and he was a geologist, he was into that. He would go around looking for fossils. And what he found was no matter where you went in different parts of the world, you could find the same fossils of the same organism. in all parts of the world. So for instance, you might go to South America and find a fossil of this fern or some sort of plant, and then you could go to Africa and find the same exact type of fossil, which is really interesting because that doesn't happen today. You don't find elephants in Africa, and you don't find, I mean, you do find elephants in Africa, but you don't find them in South America. So we have this separation of species. The fact that Wegener was able to find similar fossils of different organisms all over the world made him think, oh, this is definitely going to support my idea. And it did a lot to support his idea. So for instance, a fossil found in South America is the exact same as found in Africa. Okay, just so. Okay. He traveled all over the world looking for these organisms, these similar organisms, and he came up with one of them that I thought that was particularly good for him, this fossil called Mesiosaurus. And this was a type of reptile, sort of like a dinosaur, that was found both in South America and in Africa. And so this is very similar to being able to find an elephant in South America and in Africa. You don't find them because elephants can't swim across the ocean. So the only two assumptions you could make, Alfred Wegener said, was that either these two continents were once together, these two continents, South America and Africa, were once together, so these organisms were able to travel across this little land bridge, or somehow Mesiosaurus grew fins, swam across the ocean, then got back on land, lost its fins, and then died, and the fossils look exactly the same. So obviously this does a good job to support the idea that there's different, the continents were once together. Okay, so that's one of his clues. The other one that sort of has to do with fossils too is this idea of climate clues. And this is really interesting because he found out that if you would go to really, really cold places and you dug underneath the snow that had been built up for millions of years, you could actually find fossils of tropical organisms. So fossils of warm weather organisms were found on cold continents. He did a lot of research in Greenland with this. So he spent a lot of time in Greenland looking up stuff. What he was able to find, and you can actually look this up on the internet, today they've been able to find fossils of primates and monkeys underneath the ice of Antarctica. So this begs the question, okay, was there some super furry monkey that used to live on Antarctica and died, that was able to withstand the super cold, or was Antarctica once a jungle because it was in the middle of the world, or, it was near the equator? So as you can see, Antarctica right here is still pretty low, but this part right here, this tip of it, would have had some fossils of monkeys and those sorts of things. What he found in Greenland's up here, what he found in Greenland was fossils of palm trees and ferns and lots of big plants that don't grow on glaciers. So he had to make the assumption, again, that either these plants they don't grow on the ice. So the assumption was these plants had to grow somewhere else. The continents drifted. The fossils are still there, but the continent is completely different. So that's that's a really big clue. Climate clues. Interestingly enough, Wegener died in Greenland looking for these fossils. He was in Greenland with one of his partners, and his partner died first, they assumed, and then he died of exposure, which is death to cold or heat or whatever, but in this case it was cold. So his body is buried under the ice somewhere in Greenland. They have not found it yet. But more interestingly, I hope they find him. His body's important. But even more interestingly, he has a journal, a scientific journal that has lots of data in it that's buried under the ice somewhere, probably perfectly preserved. If you were to find that journal, you could probably sell it for millions of dollars. So that'd be a really interesting thing to find. But anyway, he died in Greenland looking for fossils for climate clues. Okay. The last one here is rock clues. And this is going to be kind of a different sort of idea here that you may not have heard of before. But what he found with rock clues is that similar rock formations exist on different continents. Okay, so I want you to write that down quick, and then I'm going to explain what I mean by similar rock formations. Because as a geologist, saying something has a specific rock formation is a very specific way to talk about something. So when a geologist says something about a rock formation, he's actually talking about the way the rocks are layered. So for instance, if I'm sitting here in Nebraska, and here's my house, and here's a tree, okay, and I would dig down underneath the soils, I would find different layers of rocks in segments, and they don't have to be the same layer, they don't have to be the same size, but they're different layers. So this top part might just be soil, this one might be limestone, and this one might be a sandstone. So very specific types of rocks. This one might be a granite, and so forth. And so that's what a geologist means when they say we have these formations. Okay, so these formations are very, very specific. So if you have a limestone, in fact, in the United States, you can dig down in most parts of the eastern United States, and even in Nebraska, we have this type of limestone called Pennsylvania limestone. You can find it in Louisville, and you can find it in Pennsylvania. You can find it in Indiana. You can find it in New York. It's all over the place. But that's because it was laid down all at the same time. Now, what Wegener found is if he took the rock formations of South America and of Africa, he found that he had extremely similar rock formations. So similar, in fact, that he concluded that they had to be the same rock formation. Okay? And this is a huge deal. If you're a geologist, you're saying I'm sold. These are the exact same things. There was no question once he figured this out in his mind that this had to be true. These different rock formations had to exist. The idea being that at one time, these were connected, but they had moved apart when the ocean started to pull apart, right? So these formations are still underneath the ground, but they had moved apart, and so now you can find these exact same formations no matter if you're in South America or Africa. So similar rock formations. Big clue for Wegener. He would take his ideas to these conferences, and he would be laughed at. A lot of people didn't take him very seriously. And he ended up dying when he died in Greenland, pretty much not having solved anything. There's a few people that supported his ideas, but they didn't really grasp onto it, mostly because he couldn't explain how it happened. So even though he was able to give all these clues, he's like, I don't know why it happens. And obviously in the science community, people want explanations of things. They don't believe in voodoo or some sort of magical thing. So they wanted to know why it happened, and he couldn't do that. So that's kind of what we'll talk about next chapter, some new clues that came about that helped him that helped people better believe his ideas. Okay, but Alfred Wegener, we have Pangea, continental drift, where the continents are moving apart from each other, and then we have three types of clues that he used to support his idea. The first clue being fossil clues, so we have different types of fossils found on the same continents. Second clue, climate clues, monkey bones being found in Antarctica, and the third clue, rock formations, very similar rock formations found in South America and Africa, which suggests that she must have been a part of, or together at one point. All right, that is it.